Hi, good afternoon, everyone. I'm Atin Sanyal. I'm one of the founders of Galileo. And we've kind of been in the business of evaluating deep learning models with a newer set of metrics, newer set of tool sets for the last 3 years, and kind of organically started support for LLMs. So rather than going super deep into the techniques that we've built for detecting hallucinations, I'm more than happy to talk about that outside. I thought I'd keep it a little more broader and sort of talk about some of the challenges that we've seen from many of our conversations with our customers who have started adopting LLMs and the impediments that they've seen in adopting LLMs for the enterprise. So just a quick draw out of the timeline in the whole modern era of LLMs. I think we started about last year when we had some of these bigger companies punch out really, really large models. And we saw later last year, ChatGPT was the first manifestation of an application. But then there have been a whole host of open source models which have come out. I couldn't find the logos for all of them, so I listed a few down in text just to show the magnanimity and the volume of models which are out there just in a matter of a few months. And there's also emerged many modes of consuming these models. Of course, there's Hugging Face, which is the popular model hub. But even beyond that, enterprises are adopting self-hosted approaches, using paid APIs from Anthropic and OpenAI and others, as well as using third-party hosting options. So with so many models and so many avenues of consuming them, enterprises have still not adopted LLMs, at least at a larger scale, and it's been over a year. So what is going on? What we've seen, the observation has been that there's prototypes and hackathons and applications which have been built. There's a lot of enthusiasm there, but there's still a lot of hesitation around adopting LLMs and LLM workflows in the enterprise. A few of the reasons why prototypes have worked great is frameworks like LangChain have proven to be really efficient at building prototypes because they provide these abstractions that allow you to construct these long chains and really go beyond just querying an LLM. Of course, the whole developer community has been very enthusiastic and has adopted it with wide arms. But the issue has been that these apps, which you see, these demos, they're fairly static. They're using static prompts. They're fairly simplistic wrappers on top of these LLM endpoints. And they lack the need for scale, and they lack the need for addressing edge cases. So fast forwarding it to the enterprise side of things, there's so many challenges which have emerged from numerous conversations we've had with customers across the Fortune 2000. Just listing down a few. These are some of the questions that they ask. Interpretability is this broad umbrella of questions which turn up as challenges. Like, how do you best interpret or best design your prompts for your use case? Prompts are often dynamic because use cases are much larger than prototypes. Is my context good? If I'm using RAG workflows, how do I quantify the health of my context? And how do I correlate them to the output of the LLMs? Hallucination, of course, is a big topic which most leaders, or at least they're afraid of adopting and their LLM applications in the enterprise because there's no real way of detecting or quantifying hallucinations, especially for these state-of-the-art models. And I'm going to talk a little bit about the hallucinations as well. I have a slide on that. But apart from that, there's a lack of guardrails, and there's other issues like input drift, and context drift, et cetera, et cetera. So a lot of the challenges, you see there's an overlap between traditional models and some of the enterprise applications of LLMs. So just going down deeper into some of these challenges and why they come across as challenges, one big issue is the experimentation apparatus is extremely slow, right? In order to figure out the correct prompts and interpret the right prompts, you need like an apparatus for doing fast experimentation. Um, there's a lack of an evaluation framework or evaluation metrics on these modern LLMs. Like a lot of the metrics which were used in traditional seek-to-seek architectures, including BLUE scores and Rouge scores and BERT scores, they simply don't work because now the outputs are no longer based on token level matching and more around the semantic meaning, and that's why there's a lot of humans who are sort of looking into the outputs and asserting them. So one of the challenges is how do you or quantify or semi-quantify the efficacy of the outputs. Apart from that, these models, they're extremely good at language. Of course, we all recognize that. But when you chain it into an application, there's a lot of issues. There's lots of crazy kinds of hallucinations which occur where the model basically talks out of syllabus. So there's almost no known metric that can easily detect that in real time. And then finally, there's the whole question of, yeah, sure, I detect hallucinations, but what do I do next? The actionable observability piece, that is completely missing. I think a lot of the actionable observability for traditional models, like tabular data models and forecasting models, I think we made good headway in the last few years. But root-causing LLM issues in real time, once your application is productionized, all that is missing. And of course, at scale, you need some sort of an automation solution so that you can sleep at night. All of this is completely missing. Here's a couple of our quotes from two of our customers where there was one instance where a chatbot application from a US bank, it started suggesting URLs which were fake. And there was another RAG workflow where the context was very sparse, and it took them days to sort of detect that. So coming to the stack itself, like how do we solve this? So this is the modern day stack. There's 4 elements to it. At the top, there's the frameworks and the libraries like LangChain, et cetera, that you use to build applications. Number 3 is the LLMs, the model hubs, and the vector databases. And finally, at the lowest level is the infrastructure to train and serve these models. What's missing is this methodical evaluation layer, which we try to sort of fill the gap in. So diving a little bit deeper into the 3 tools that Galileo has. Of course, I mean, this is more general, so take these as principles. So on the prompting side, you need faster experimentation. So Galileo allows you to do prompt sweeps. We give you granular explainability into the prompts, the context, and the output. So there's these 3. There's the query, there's the context, and there's the output. You need token level explainability to see where the model was confused and what parts of your prompts and your outputs can you change. If you're fine-tuning LLMs, which is an emerging trend, how do you curate the right data set? Like how do you remove errors that pull your model performance down? And finally, once you productionize either your fine-tuned model or your LLM workflow, if you're prompting to productionize to production, how do you monitor? Monitoring token lengths and costs is one thing, but how do you monitor hallucinations in the output? That's the new challenge. So what we've done at Galileo is we've built this suite of tools which are essentially completely algorithmic. Like they sniff the log probabilities from these models, and we do statistics on top of it to give you quantified measures of things like hallucinations, factual correctness, groundedness, uncertainty, model confusion, and many others out of the box. Beyond that, we've built a suite of APIs which allow you to leverage these metrics and automate the detection of these in your production applications so that you can sort of not only apply guardrails, but get alerted and root cause quickly and point it back to the data that caused it. Here's a quick sort of view of the Galileo tool. Of course, I'm more than happy to give you a demo if you just step out here. This is on the prompt side. We allow you to do experiments, A/B comparisons. The real main thing is the quantifying these the inputs and the outputs. So over here on the screen, you can see We have the reds and the greens, which sort of show you token level explainability, but also it allows you to choose these metrics. And we have a metric store, which is expandable. You can add your own metrics as well. On the fine-tuning, we've been in the business of fine-tuning for 3 years. Essentially extending it to seek-to-seek models. We give you a lot of explainability into finding errors in your data. And then finally, of course, monitoring. The main thing in the monitoring side, beyond monitoring cost and token length, is monitoring things like hallucinations and factual consistencies, et cetera, which get provided out of the box. Here's a super quick view of the hallucination research we've done. We've done it on state-of-the-art models. We used a technique called detailed chain of thought. So behind the scenes, we are using chain of thought prompting to make the model realize its own mistake, and we give you an explanation of it. And the numbers that you see, the green cells, they're essentially benchmarking against a manually curated hallucination data set evaluated by domain experts, which we've curated. And we've got 85% accuracy at detecting hallucinations, which is quite a good achievement by most ML standards. Here's some interesting examples from ChatGPT outputs, completely made up quotations from Shakespeare's things, non-existent books, non-existent URLs. We're very easily able to sort of find with our score. But anyway, that's the talk. I'll stop. Any questions? Happy to answer.
Is there a way to use this to detect hallucinations at a more user-friendly level yet?
Yeah, absolutely. So what you didn't see in the tool, I can show you in the demo outside, is there's a score that we assign. It's a score between 0 and 1. And think of the score as, say, if you asked 5 humans, experts, whether it was factually consistent or not, and say 3 of them said, yes, it was, and 2 of them said no, then the score would be 0.4. So there's a score that we give, and we explain it in very simplistic terms. So I think that's been one of the key ways that people assert whether it's actually hallucinating.
Thank you.
All right. Thank you so much, and have a good rest of the conference.